So we've already done that. Everyone's welcome. Come join in. Sponsor MicroPython if you can. That's great. I've got the news roundup. I've also got a very brief thing to show about documentation. I did some updates to the docs recently and thought I'd just briefly show how it all hangs together. The reason I'm doing that is because I want you all to help. So it's not completely, yeah, it's a big good thing to get more people to be able to help. Barry, this is a slide from last month, which I think you're away from, but I really, really appreciate your help here. For everyone's who hasn't heard, Barry's been helping with the videos. So he's been kind enough to process them after I just hand him the videos as a big lump, and he cuts them up and titles them and then uploads them to YouTube for me. It's a huge burden off my shoulders. Thank you again, Barry. And then I just need to create a blog post and they're archived. So that's great. If others want to help, there's other things we could do as well, but come reach out if you can. Headline, I thought I'd reach out to our Adafruit friends because it was CircuitPython Day recently, and they had a whole bunch of things organized. The whole day was put aside by Adafruit to do a whole bunch of presentations, and there's a YouTube channel you can go have a look at. It was hosted by Paul Cutler, who does the excellent CircuitPython show. It's a podcast that you should stay tuned to over the next couple of months for reasons I can't share yet. Some of the things that were discussed was some information about CircuitPython. They had like a game jam, which was pretty cool, by Tim or Foamy Guy, where he sort of walked through how you can build a game in CircuitPython. And there was a preview of CircuitPython V8, which is just around the corner. They're in beta at the moment. It's a really important release for them because it gives them the web workflow, which allows them to use ESP32, and they can edit files over Wi-Fi. So yeah, it's good hearing about all the interesting work that's going on over there. I think you covered most of these, Damien. Is there anything that's... Yeah, I think you covered all those. It's good.
Oh, well, 17 improvements, yeah.
Yep.
We not merged. Certificate improvement, yeah. Packaging discussion didn't go over.
No, no.
Yep. We should leave that till next time, probably.
Yeah, it was just sort of activity, not necessarily stuff that's gone in, but there's been a lot of discussion about packaging. And yeah, that's put in a lot of effort on the SAMD improvements. So maybe next month we can talk a bit more. We've already talked plenty about that. I think we've covered all those points. Yep, cool. That's new hardware. I didn't get time to package this nicely, but I did receive some of these guys, which might be really hard to see. But it's a rotary encoder that you can get called the T encoder. Both of these were from LilyGo this month. So this thing rotates around as you would expect a rotary encoder, and there's a button in the middle. And it's got an ESP32 driving this thing. So it's, you know, it's a Wi-Fi connectable rotary encoder. And it's just got 8 pins that you can plug it down to your own board. Caught it. It's quite neat. A couple of LEDs on it as well. I think we've talked about it in the past. It's quite a nice little board. I've already got it running with a library by Mike Teachman, which allows us to query the rotary encoder. Yeah, I'm just going to put you on mute because you're noisy. Yeah, it's a really neat little device. There are a few of these kinds of things on the market now. Some of them are really expensive, but have like acceleration and they get really fancy. Some of them can even be driven by software. These are $17, I think. They're quite affordable and quite neat.
The T encoder one requires one of their little dongles, doesn't it, for connection?
It does. So
it's kind of annoying for me anyway. I find that just,
it is
like,
annoying.
Why can't you use the standard?
Yeah. The reason they've done that is because they're using ESP32 in a lot of these things. So ESP32 doesn't support USB. So this is actually it's USB with an extra couple of pins on it, which this thing takes advantage of. And so they put the serial converter chip inside this little dongle. And that's because they've got quite a few boards that are coming out that are quite small, and so I guess that's the trade-off they've chosen to make. You only need one dongle for all of their devices, but still, yeah, I acknowledge it's a bit of a pain. It's an interesting design choice, if nothing else. I also found that I couldn't program it from WSL, just for reference. I don't know if that was just I was having a bad day or not, but I don't know if there's something different about it that's confusing it. Speaking of TTGo, the other one I had was the T display, and this is a bit hard to see, but it's blurring it out like that. But it's a beautiful display. We've covered this one before as well. Really nice high-res display in quite a small package. I'm quite excited about this one, and it's got an SPS3 on it, and it's got a parallel connection to the display, so we should be able to make that quite fast. I'll keep you posted where we get with those. In hardware news, more S3 boards are popping out as availability becomes of the S3 becomes more available. This one is by Wemos, and I guess quite a few people are waiting for it because Wemos tend to do pretty good of the cheap ESP-based devices, expressive-based devices. So this thing's got 16 mega flash and 8 mega RAM. Got the dual USB ports, 30 odd IO, and it's $10. It's pretty good value. It's kind of similar to the Banana Pi Leaf that we've talked about, and they've made some different trade-offs here. Less flash, less PS RAM, and less flash as well. Yep. And only one USB port, but this one has battery charge circuit and more GPIO broken out. So it's similar sort of price. So you've got two good options there if you're interested in using the Expressive ESP32S3. And there's plenty of other good options as well, of course. Does everyone know what that is? I'm sure if you grew up through the 80s, I guess, you probably recognize Doom running on a small little microcontroller. This is the EMF 2022 badge. EMF's a conference that goes on, and every year they've made a MicroPython compatible board. This year's looks like that one. That was actually one of the preliminary designs. They made it look a bit more fancy when they released them. But it's S3 running a display, little joystick, and some I/O expanders. That's a double board, so they sandwich the components in between it with a battery in there somewhere. That board in itself's a really interesting thing, but I think it only went out to the people who were attending the conference, so really hard to get a hold of otherwise. But the key thing here is that Phil Ashby managed to get Doom working on this thing. And most of the Doom work was already sort of in place as he was using a GitHub available port of Doom that does work on microcontrollers. The main constraint he had was he wanted it to work alongside MicroPython because the EMF badge already has a way of getting applications onto the device. So they've got this system called the Hatchery, which allows anyone with one of these devices to choose and download projects to it. And so he wanted to take advantage of that system. So you can please read Phil's article on this. It's fantastic. He's basically started down the path of making a native module in MicroPython that, so building an MPy file. Ran into some problems with that approach, had to go down some other paths, and I'll let you read the write-up. Also identified a few bugs along the way, but in the end, he's got this thing running. He's managed to get Doom running it's all written in C, but the MicroPython interpreter runs alongside it. It's really cool. It's really impressive bit of work. And it runs pretty smoothly. Yeah, I thought it was cool. Also, Matt Booth, Damien, you mentioned Matt before. I'm sure this is where his Polygon stuff came from.
Yeah, I think so.
Yeah, so he was also running these things on the EMF badge. Basically, it had a 3D renderer, which you can either have a cube or the classic teapot displayed, and you can rotate it around and spin it about. So that was really cool. Good to see that an application like that has made its way into upstream MicroPython features. Oh, you can sort of see in the background, this is the slightly fancier board. They've got a really cool screen print on it as well. Thonny went through another release, version 4. So Ava released this. It's really hard to summarize the changes because there's heaps of them. It reads almost as long as the MicroPython release notes. There's heaps of stuff going on. And you got to say, like, Thonny's a great choice for particularly beginners to Python on hardware. It does a lot of really interesting stuff. So yeah, go check out version 4. We mentioned PyBricks before, Lawrence Vork and David Lechner. I'm sorry if I'm saying your name wrong, David. So I hadn't really, I was sort of aware of PyBricks, but I didn't know that much about it. But it turns out, yeah, it's another MicroPython distribution, as we mentioned before, but it also includes it's a web-based code editor as part of their system. And so it looks like you can deploy code over Bluetooth even. And the other part of it is they have a bunch of example projects. I've got some screenshots. That's what the editor looks like. I mean, it's fairly basic, but it's exactly what you want to play with. They've got good documentation on the APIs that they provide. And a really cool part of it is they've got these projects. So if you've got like one of these amazingly complex Technic, I've got to get one of these. I just want one of those. If you've got one of these Technic packages, you can, with a couple of clicks, sort of have an example project running. You can deploy the firmware from the code editor, and you get moving pretty quickly. It looks like it's packaged really well. Kudos to the guys for doing a good job there. The other thing I really liked was that you can actually, you can't see it here, but you can also recover the original Lego firmware as well. So I like the fact that they've sort of thought that, okay, you can put their firmware on it and do whatever you want, and then you can drop the original stuff back on there. It's really nice. So I believe the firmware deployment relies on Chrome features, as most of these in-browser editors do.
I think Andy had something he was trying to say.
Sorry, I shouldn't have spoken over you, Matt. I was just saying it's only Bluetooth. So yeah, it requires web Bluetooth to do the deployment, and then it's you're only deploying via Bluetooth. Right. Yeah, I've got the Lego Droids kit with R2D2. It's a really neat, and they've got a recipe for that as well. It's really cool.
Yeah, I mean the projects that they had chosen were like drool worthy. They were really nice Lego packages. So I might have to get my nephew one of these Lego Technics packages and give it to him for Christmas next year after I've had a chance to play with it. Andy, you were referring to the machine learning article by Simon Salerno. Really good article. So the idea here is to use a classifier created with TinyML and use it in MicroPython. But you actually use it in a few different areas. He's looking at using TinyML trained, particularly classifiers, on small devices. Now, he can even get things running on like AT-Tinys and stuff like that. And it's done with a package that he's written called Everywhere ML. It's a GitHub project you can go check out. And you can train models inside Everywhere ML, and then you can export from it. And it has a number of different exports. And one of them is a MicroPython export. So you can take the classifier that's trained and create regular MicroPython code that you can then just use. So an example of how you would actually use it, it's really simple. This is the part that actually gets generated, the random forest classifier. MNIST is really, it's just the classic sort of recognizing numbers that are handwritten. And so in this case, he creates a classifier and he gets the classifier to predict based on some data that is from the MNIST package, and determines if it's a 0, 1, or a 2, or 3, or whatever. Really neat way to do it. And the other thing that I really liked about it is that he's using Ginger and a little bit of Ginger wrapped goodness to create these templates. If you've used Ginger before, it's a templating engine in Python. And so, yeah, I guess the idea I had is that we could add other exporters, because this is quite slow, is one of the things that he found, because it's doing it all in regular Python. It would be really interesting to explore whether it would be possible to create like a native module exporter. I reckon that would be really quite interesting. I can see that someone's commented. I haven't read it yet. Yes. Yes, that is the, and he's posted a link to the tweet that had it. I can't remember if I've got a link here or not, but yes, Arduino. And the write-up's really clear as well. He's done a good job with it. I like it. Belay made a bit of, I don't know, it just seemed to be linked everywhere. And it's quite a simple idea, but it was packaged quite nicely. So the idea is that sometimes you want to control your MicroPython devices from CPython. Now, you probably know that we've got capabilities to do this with MP remote at a high level or with PyBoard at a lower level. But Belay does package it nicely. You can see here that you just create like a connection to a device, and then you just add a decorator, and that decorator basically indicates that this method gets minified and then sent to that device. And so you run this on a regular PC, but it runs MicroPython on a device that you've got connected. So it's a neat way of being able to control other devices, or MicroPython powered devices. I think we should probably consider adding something like this upstream, Damien. I don't know how you feel, but it's a neat model.
Yeah. I guess if it was just integrated into PyBoard, maybe, or MP remote as an MP remote lib.
Yeah, we probably might want to start thinking about whether we should separate the MP remote into more of a lib. It's a little bit, it's mostly there, but yeah, not quite as usable as something like
you can use it as a lib. It's just
you can import MP remote, or if you've installed it and if you pip install MP remote, you should still be able to import it. But yeah, then it's worth thinking about whether you want to put a public API on the functions like this.
Yeah, and we've obviously got no documentation to do this kind of thing. So yeah. But I was shocked at how widely this was linked to. Like every man and his dog seemed to do so. Partially because it was quite a neat article that was written by, I think it was Hackster. Yeah, Hackster.io. So yeah, they explained it quite nicely. I think people like the idea of being able to control devices from CPython. So yeah, makes sense. Anyway, that was Belay.
Yeah,
had a really cool logo too.
So just quickly, I've actually written a library that does this, but that's so much more elegant than what I did. Yeah.
Yeah, it was quite neat. And I haven't dug into everything, but I did see that he'd taken the time to like minify this. So he actually strips out comments and whatever before transferring it across. So it's quicker to transfer. So yeah, it's quite a neat idea. Yep. Microbit editor. I haven't finished this one off, but Microbit released a new version of their editor.
Yeah, it's really good.
It's really nice. Yeah, it's really
very polished.
I think it was this one. It's well worth having a look quickly. Come on.
Yeah.
It's another one of these in-browser editors, but it's almost fun. For starters, I really like the way it's doing the syntax highlighting. It's quite neat. You can choose like different modules really easily. They got suggestions on what you can do with those kinds of things. I thought it was great. And again, you can deploy it from the browser, which is nice. I like it. Yeah, how cute's that? Anyway, it's worth a mention. Go check it out. I'm not sure if it's constrained to the V2. Damien, I don't know if you heard.
I don't think so. I think it will be V1 as well.
Okay.
Pretty sure. Because they're both very compatible.
Yeah, right.
Like the same code runs on both of them.
Right. We don't manage that.
No, we don't.
No. Yeah.
No, they're in separate repositories. They're in they're in other repositories, but there is some thought about merging V2 into mainline MicroPython.
Right. I guess the problem is that its syntax is a bit different.
Syntax?
Sorry, for the accessing a lot of the APIs. The microbit was always a slightly different flavor of MicroPython. That's the same?
Well, just that it had modules. It's just because it's just got modules that are different. Like,
okay,
and no reason we can't have those modules elsewhere, like audio and speech and the microbit module. You could have those, but they're very specific to the hardware.
Yeah.
The language itself is just MicroPython. Yeah,
it's a bit wonky, but yeah, like the pins are a bit different.
Well, the pins are totally different because it's microbit.pin. It's not machine.pin.
Yeah, right.
But it's not like it's machine that's been changed.
Yeah, it is separate. Yeah, clearly separate. Oh, yeah, you're right. So all these things must work on both, and then V2 stuff's marked. Cool.
Yeah. Romilly's right. Then I2C is different, but again, I don't think it's machine.I2C, microbit.I2C. So you could add the machine module and then it would work. And on the V2, there's enough space to add the machine module. On V1, it was very, very tight, and there was only room for the stuff that was designed from the beginning for the microbit sort of teaching experience.
Yep. Yeah, it looks like quite a neat editor. I like it. We shall push on. Can I do that again, or is it going to start? It's not quite there. Seed Signer is one of these Bitcoin wallets or a crypto wallet. And Keith Mukai has been doing a lot of development for MicroPython, or on his MicroPython version of Seed Signer. They've actually, it looks like they've been looking at using the Raspberry Pi on a bigger device, or at least Raspberry Pi Zero on a bigger device. But they've also been experimenting using an ESP32 as well for a small device. And one of the cool things that, if you go look at this tweet link later, they're using like a wave share display, and they've compiled LVGL for these devices, which is something that the LVGL team hadn't supported per se. So it was really cool that they were able to get a driver working for the display they had and get it running on the ESP32. So yeah, go check that out. It's really good. I'm not a big fan of crypto. I think it's on the whole a bad idea in general, but if you're into that stuff, it's quite an interesting project. Bitloonies I haven't had time to write up, but it's definitely worth checking out. If you haven't come across Bitloony, he's a quite famous and notorious maker. Does all sorts of really crazy and very interesting projects. I think this is his first MicroPython one, and so you can see he's got this LED matrix here, and he ended up controlling that from a Raspberry Pi Pico, and he ended up controlling that from his PC. So that the LED matrix was actually duplicating his computer screen. Obviously, at a low res, scaled down, and it was all blobby, but it looked really cool. And so he did this in I really like the fact that it was kind of like clearly a prototype. Like he used some browser code to actually share the screen. So he's using Chrome to access his screen. And then he used some JavaScript to scale it down, and then he pushed it across the wire, and it all just sort of hung together. It was a bit slow and clunky, but I think I poked Jim, and Jim has been in touch with him for some suggestions on how he can improve it. He was thinking about going down using C++ for it, but a lot of it wasn't MicroPython slowness. It was just choice of design decisions. Yeah, go check it out. Really good. He always has great videos, well worth a watch. Core Electronics have also been doing some more. They've been continuing to do more MicroPython videos. These were both fairly simple and straightforward. I'm not sure how many web server examples we need to see on the PyPKW, especially ones that run at the socket level. There's a lot of them about now, but both of them talk about connectivity, which is obviously, it's a killer feature of the PKW, like the ESP before it, and CC3200, I guess, before it. Yeah, check it out if you want to, because Tom's Hardware, Les Pounder also covered it as well. And Romilly, I'll get to you in a second, but yeah, I'm sure you've got a bit more to say on that. Bruno created an amazing to-do board with the Pico. This is for like recurring to-dos that he had. And really simple, but obviously just each he had to scratch. LEDs with buttons and a very simple schedule in the background, so it just reminds him to do something periodically. But really good write-up, code's all available, well worth a look. Scott did a great little display of NASA's astronomy pick of the day, which is a very sort of famous site where NASA always posts a typically really interesting astronomical picture. He's using the Pymorania Display Pack 2, which is a pretty good resolution little display, and something he sort of what did he say? Is it a secret or a hack or something? But really neat idea where he's got a Pi0 in the way as well, which hosts a web server and scales the image before it grabs it on the device, saves memory, and makes it much faster. So it's quite neat. I hadn't had a chance to write much about this one, but it was a really cool idea, using MicroPython and one of the M5 stacks as a tachometer. So it's using a reflectance sensor to calculate the rotation rate of this fan. Quite neat. I'll post a link for it at some point. Quick Bytes, the wibbly wobbly timey-wimey atomic clock, which also, apart from having a catchy name, uses a PKW to get the time and then displays it in an interesting way on this acrylic with neopixels display. And I'm going to say Sonethmember developed a coin counter using OpenMV. And so this was interesting, like you can plonk a coin down in the view of the camera, it detects which coin it is and then adds up the total. Yeah, neat idea. Eddie created a garden dashboard. This looks really good. So a lot of the reason this looks great is because he's gotten some great canvas JavaScript going on. And it just basically takes a whole bunch of sensor information for sensors that he's packaged in. This is a birdhouse with a capacitance sensor on it and a few other bits and pieces. So he can get information on his laptop. Mikey, I don't know his real name, Mikey, but has some really cool, he's been having fun just LED scrolling in omnidirectionals. So it scrolls left, scrolls right, up, down, every which way. And I thought it was a nice little quote too. Can't express how enjoyable it is to use MicroPython, which was nice. And just on that, sorry, Romilly, we'll get to you. It was really interesting looking at this. You'll see the Twitter thread if you go look at it. You can sort of see him unlocking a different feature. It's like, oh, great, it's scrolling left. Oh, now it's scrolling right. Oh, now it's up and down. And you could just, I could almost hear his enthusiasm as the Twitter thread went on. Yeah, Romilly, so you appeared on the PyCast, which is Tom's Hardware's, is it a weekly? I can't remember. Weekly or monthly or?
I think it's monthly.
Monthly. Yeah, I think you're right, actually. They have a video podcast, I guess you could call it. And Romilly was on it talking about the PKW and some of the projects you created with it. So, yeah, was there anything else you wanted to say on that? Or
only thing really is two things. One, at the moment, progress on the guide has been slowed down a bit because I thought I'd trashed my system disk. It turned out to be my home disk, which got trashed. So it's not surprising. It's old, and it's taking a while. I've got everything backed up in various places, but recovering from that kind of thing always takes a while. So that's why I haven't been doing quite as much as I'd hoped. But something that I would love some help and advice with, not for the guide, because I think it's too big a project, but I would really like to do a good tutorial on MP Remote.
That would be great. Yeah, we certainly need it.
As I've come to find out more about it, I realize how incredibly useful it is. And indeed, although I love Tony, I've become very keen on Tony, I still really feel the need for an automatable deployment process, because Tony works superbly if you've got a single file or one or two files that you need. But if you've got a ton of stuff, and because I tend to break stuff up into very small reusable chunks, I tend to have 7 or 8 files in a project. MP Remote does that job really well, but it does so much else as well. So I'm not sure where the best place is to ask for help and suggestions. But
I would have said Slack, but either Slack or Discord would probably be the right place to.
Yeah, because I'm kind of a novice myself, so if I write a tutorial, it's going to have an awful lot of holes and quite a few mistakes.
Yeah.
Okay, I'll go with that. Thanks.
I should mention Rumley's referring to a guide for the Raspberry Pi Pico W. So he's running quite a detailed guide on taking someone through how you might use that device. Yeah, you might also want to talk to Sion as well. Sion's done a couple of tutorials, and they've come out quite nice. So you might have some suggestions there.
If someone's done a good job, then I'm happy to refer to it.
No, I think
I didn't find anything that really spoke to me.
It's still been under heavy development, so I think it's probably due for another good take on it. Yeah, like I don't know anyone that's had like a video tutorial, for example, that covers the mounting option, which is a killer feature in its own right. So yeah. Anyway, we'll push on. Thank you. Building docs locally. I might skip this actually. I was going to talk a little bit about building docs, but it's getting late, and maybe we'll cover this next time. Yeah, I think we'll cover this next time. My throat's getting hoarse. Does anyone mind if we cover docs next time? What I intend to cover is using a container to build Sphinx and to host it, to host a little web server so that your browser can look at the docs as you modify them. So hopefully it's useful for I found it very useful for editing the documentation and seeing the changes pretty immediately. Maybe if we have a talk later, I might revisit it, but I'm starting to get hoarse in the throat. Just a couple more then. So destroying RP2040s for fun and science. There were 2 things that I saw that were really interesting. Overclocking an RP2040 to 1 gigahertz. This is by an intern at the Raspberry Pi Foundation. And I thought a couple of the quotes were pretty interesting. Okay, Andy, thanks. Yeah, I used a Peltier cooler to get the temperature down at -40 Celsius. And the chip duly died after being at such a high voltage. That voltage was, I think it was above or around about 3 volts, when normally the internal voltage is about 1.1. It hasn't been able to turn on since. So it ran long enough for him to run some benchmarks on it, and it ran them very, very well for a very short time. And I think we've got a picture of it running right there. I thought that was pretty interesting. Never seen a Pico in that form before. The other one was a silicon level teardown of the Pi Pico W. So someone had actually done some like analysis, like this is the Wi-Fi chip that is in the Pico W. I wasn't aware that, but according to this article, the Raspberry Pi Foundation actually did the package, did the module. So they bought the silicon part from Cypress or whoever the company is that owns this now. But they did all the surrounding circuitry, including the bandpass filter and the antenna. Of course, they purchased that, but they packaged that whole thing. It was quite interesting. Points if you can identify what this is. Any guesses? No.
Is that the motor?
No, it's something that makes RF possible in these small packages. It's an inductor. So previously, inductors required a lot of manual hand winding, or maybe not hand winding, but it requires quite a lot of investment and cost in putting together inductors, and they're large. At some point, someone figured out that you can build one into silicon, and that is really what enables a chip like the Wi-Fi chips that we use in the ESP32 and from Cypress and Pico W and so on to function. So that was really interesting seeing it in the flesh. And I guess this was another interesting photo from the document, which is talking about the silicon level chips. So you can see that's the actual RP2040 flash. It's power chips. So you can see they're all similar size, and the Wi-Fi chip is massive. And part of the argument for why Raspberry Pi Foundation would have kept them separate is because of this reason, right? Like you pay for silicon, and the complexity of squeezing all that thing into a small package that's integrated is quite difficult. So probably a good decision to keep it separate. Anyway, I thought they were interesting pictures and observations. I think that's all I got for you. Yes, that's it. I am done. There were other things, but we didn't cover the time of flight sensor, but that's Maker.io. Via DigiKey, I've put a tutorial on using that time of flight sensor, which is a Pi chip. I've got another. Yeah, there's other things. If you've got a QT board, there's a breakout board on Tindy available, which might be interesting to you. Andrew, I don't know if you had much of a read on this, but this is you're able to do remote black magic stuff. Did you have a look at this? Or because I know
the firmware behind it, they've based it on another project that's been around for a while to do the same thing. So you can turn any ESP chip into a remote SWD debugger that just directly hosts a GDB server. So it's just a remote socket to the GDB server. And they are, Blackmagic in that sense is a really cool project. It means for using actual in-circuit debugger, you don't need something like OpenOCD running on your computer. Like the whole amount of that is running directly on the Blackmagic dongle or probe, and it's open source. You can flash it onto a whole heap of different hardware, and GDB just talks to it directly. Yeah, sort of the downside to the official Blackmagic probes is they plug in on USB as a serial port, like a USB serial, and you have to faff about with GDB to find the right serial port and connect it to. Whereas you're running it on an ESP, you've got just an IP address that you can talk to instead, which find is actually far more controllable than a serial port on desktop.
Yeah, one point is though it doesn't yet support ESP32 targets, I don't believe. So you've got like STM32, SAMD, stuff, RP2040 recently added. So it's a shame. I think it's a work in progress.
Cool. I just noticed that Sobs was involved in this as well, which doesn't surprise me. It's right up his alley.
But yeah, this is the original project, isn't it? The actual thing you link to someone
I think
building and selling,
right.
building and selling code, a board to do this, and they've got a fork of this particular firmware package, which apparently they've reworked a lot. I don't know, I haven't looked at what they've added to it yet, but
Right. That's right. It's deep
Same.
in the links on my other browser somewhere.
Yeah, the little board that they're selling soon looks quite good. Like it's got a fair few bits of functionality on it.
Yeah, right.
We'll wait and see how much they charge for it.
Cool. All right, that's it.